Hello there, and welcome to the third and final session of the student workshop From Zero to Civ, Sustainable Future. This is session 3, Localized Resources. Now, in the previous two sections that we went over, session 1, Human Needs, and session 2, Cyclical Systems, we talked about a lot of different things. We talked about the UN Sustainable Development Goals. We talked about how to go about creating your own sustainability project. We talked about the kinds of things to consider in the long term, looking at how different systems interact with each other. This time, we're going over something a little bit different, and a lot of it may seem common sense, but the point of it is to ideally change the way that you look at resources and access those resources. So let's go ahead and get started. We want to first look at the point, which is problem solving. Now, when you look at problem solving, any kind of problem you might have, it might be that you're focused right from the center on the problem, on the goals that you have, the outcome that you want, and about the values that you are going to use to focus the way you get there. This is important. But sometimes you want to be able to come at these problems from different angles. So it's always important to be able to remember not only the sorts of ideas that you're coming up with in your group, the needs that you've got for your community and for yourselves, the predictions that you've got. This is the ideation side. Keep this in mind, but also look at the resources that are available to you, the skill sets and interests that you have represented in your group, not just your own, but those of your friends, your families, and the opportunities that may exist in your community. If there is some kind of a contest, if there's some kind of a school assignment, if there is some kind of anything at all going on that can be linked to what you're doing, then jump in and make it something that is more valuable to you. This is the real power of the Create Your Own Sustainability project and of Zero to Civ in total, is to really make education yours as a student. Because as soon as you relate whatever it is that you're learning about to something that you already care about, it becomes twice as easy to not only pick up the details of whatever it is you're learning, but also to retain them over time. This is something that, honestly, I think should be gone over a lot more. But for right now, just consider it this way. You enjoy something, your hobbies, your goals, sports you like, the problems you want to solve. Those are the central parts here that you see, goals and values. If you can link those to anything you're studying, it becomes easier. That's the part that matters. So keep these things in mind. If you're having trouble solving a problem coming from one direction, come from another direction. Take a little time to breathe. Play a game. Make it something different. And answers, if they matter, will generally come to you at those other times when you're focused on other things, when you're daydreaming, when you're playing games. That's when you start making the connections. And that's the thing that people don't tell you about science. It's not in the lab when you're looking at samples with chemicals bubbling in the background. That's not where you make the biggest scientific advances. Stories about great scientists and great minds almost never take place in the lab. They take place somewhere else, where you're with family or thinking something else, or just, shower thoughts. You're sitting in the park looking at birds. You're watching the clouds go by. That's when your brain makes the connections. That's when your brain solves the bigger problems, makes intuitive leaps. So always make sure that you're getting that time so that you can really make the most of what you're doing. Now, in order to jump into the topic of localized resources, I want to start with the topic of analog versus digital. Now, If you're young, which you may be, analog and digital may just be words. Your parents, your teachers, they might have grown up in a world that had analog in it, pre-digital technology specifically. But not knowing the difference, you might not understand some of the major changes that have occurred in the world. So let's put them into a perspective that makes a little bit more sense. Not because you necessarily need to know about history, but because you need to understand how to influence the world that has been put together by people who were brought up by analog, by pre-digital technologies. A lot of the different systems that we've got in place are there not for good reason, but because that's how you had to do it before, and you don't have to anymore. Let's take a closer look. This is prehistory analog. Anything that is pre-digital. So digital refers to the binary language, anything that communicates in ones and zeros. So most computers use ones and zeros. Sometimes you can also use hexadecimal and other different coding languages, but effectively most of that came after binary, and that was the initial language that was used in order to communicate with machines. So binary was actually invented back in 1681, which a lot of folks don't realize. This is way, way back. I mean, before America was a country, before you had a lot of things going on. Effectively, there were still pirates on the ocean using lamps that ran off of whale fat. I mean, it was a very different world back then. But it was 20 years before anybody even knew about the invention of binary. It was 1701 before it was actually recognized by the scientific public. Now, why is that? Why would it take that long for the message to get out? In the 1600s, you weren't sending email. You weren't doing anything like that. If you wanted to get science noted, if you wanted to get an advance understood, you had to write articles about it by hand, usually. You could get printing done at this point. It was a fantastic advance at the time. The printing press was amazing. You could actually make a book and not have to write it by hand. Great technology. But because of this, things went a little slower, and the scientific community at large had to get together and look over articles about these new technologies and then accept them, and that was how they got recognized. You got the word out by getting these pamphlets and books by mail, by horse-drawn carriage or steam engine taking the information to you. It was a huge delay. In fact, it was 1946 before binary was actually used in a computer. So this was the first digital computer. Now, when we talk about computers, effectively all you mean is a device that can make computations for you. So there were computers before 1946, but none of them were digital until then. Now, I'd like you to look at this picture. Tell me what it is, if you can. It was part of a mechanism, an extremely old mechanism, as you can guess. If you'd like, you can take a second, form a guess with friends, ideally. It might be that you've seen this picture somewhere. And if you have, great, awesome. If you're big fans of archaeology, it came from the world's first known computer, which is called the Antikythera mechanism. It dates back to 60 or 70 BC, and it was found in a shipwreck off of a Greek island with the same name, Antikythera. and it was used as an orrery, a method of calculating eclipses, astronomical positions. It was used as a calendar, but this is a reconstruction that you can see here. The mechanism was very simple, a hand crank, and with it you could see the date, the month, the sign of the moon, different planetary positions. There may have been, and probably were, older similar devices, but this is the oldest one that we've found. Now, for devices like this to date back that far, but only really be in use the way they are today, this talks a little bit about the adoption of technology. This is that first digital computer that I mentioned before. It's called the Eniac, the Electronic Numerical Integrator and Calculator. It was put together in the US, and effectively all of those different components that you see along the walls and in the middle there, all of those are part of the same device. But the thing is, this computer, if you put all of the pieces together, it was over 30 meters long. It was 30 tons of material. And it came to being in 1945, about 46, it came into operation, and it was only used until 55. So about a decade was its entire lifespan. And this was an amazing device at the time, but of course it's absolutely nothing compared to any kind of computing device you may have ever seen in your life. The cheapest and oldest cell phone that you've ever seen is more powerful than this entire device. But this was a huge advance, and it changed the way people looked at calculation. This is your effective digital timeline. When you want to look at the Eniac, that was back in 1946. Of course, the invention, as I said, was in the 1600s, 1682, but if you want to really talk about digital, you're talking about digital technology being accessible to people. And that was 1982. That was with a Commodore 64, which was a computing device that you could hook up a set, and you could use it to play games, and you could use it to do basic coding, and there were a lot of interesting things that could be done. But this is where the general public actually got access to this technology. And by 1990, you started to have more personal computers being sold. By 2000, suddenly you had a huge jump, not only in the amount of people with a personal computer, but the amount of people who could access the internet worldwide, up to about 19% then, and about 11% of the world with cellular phones. By 2020, we were up to 62% of the world population being on the internet, and 59% having access to cell phones. And you might see in the numbers here that that was a bit of a drop in the internet percentage from 2010, but that's only partially because of the amount of the population that had expanded by that point, and a few other odd statistical indiscrepancies. Anyway, when you look at this, just up to 2020, we now have a world that is significantly more connected than it was. And that's one of the things that I want you to consider. That it's not just that you might be able to get access to a digital device, to the internet, to communications networks. It's that everybody else can too. And that's beautiful. Because that means that even if you can only get to it once a week, it's still the ability to reach out and communicate and coordinate larger scale projects. Now, I want to show you a couple other things. This is the Pulsar. This was high technology at the time that it came out, 1972. It cost $2,100, and this was quite literally something that James Bond was shown wearing. It was that advanced. It was the first digital watch. For inflation, to 2021's values, that's about $13,500 worth of wristwatch. which is crazy. It's a lot of money for a wristwatch, especially when the exact same technology, let's take that back, faster, more efficient, more cheaply made technology that does the same thing can be now acquired for less than $1 in any color you'd like. Now, they do effectively the exact same thing, the Pulsar, and this amazing example off of Alibaba out of China. But the difference is what we're looking at. This is what we've been talking about so far the entire time. It has been the idea of access over time. Now, again, those of you who were here, and ideally all of you were here for session number 2, talking about circular resources. Ideally, you recognize that this is almost exactly the same equation that we had there. Change over time was what we had before, delta over t. But now we've just taken that bottom line and moved it up a little way, and it's an A. Access over time is what has changed. Resources are more accessible. Skills, education, and training are more accessible. And because of that, change is more accessible than it has ever been in the history of our species. So, anytime you feel like there's something that cannot be done, that's too big, that's too difficult, remember that there is access now that we have never had before. It changes the game. So I want you to be able to approach problems realizing that any kind of old rules that existed, they don't necessarily exist the same way anymore. What matters now are your goals and your values. And if you value people being able to have access to resources, people being able to live a more sustainable life, you've got access to change. We're going to give you an example. Let's talk about the oldest known profession, the oldest documented profession. Keep it clean. Drafting. Do you know what drafting is? You can take a minute. If you don't know already, there's no need to look it up. I'll go through it. But what could it be? This is an absolutely universal profession. It's been used all over the planet. It was central to the early success of the Chinese and Egyptian empires. Effectively, it's something that any one of us can do. And it's central to the development of technology. All drafting is, effectively, is drawing. Now, let's go back a couple of hundred years from where we are right now. It used to be that if you had an idea for a machine, a part, something amazing, you would go to what was called a drafting board, a drafting table. And it was huge, it was upright, it looked like an artist's easel, but bigger, and with big interesting devices on the side of it. Effectively, all it was a way for someone to be able to draw really nice circles, straight lines really easily, and to be able to stand and work at something in incredible detail so that they could design a part that could be produced in a machine shop. That was it. But effectively, what you needed to do, as you can see in this illustration, if you had an idea for a part, that little green thing that you see on the screen, that's what you have in your head, this L bracket. You would have to be able to think about it and look at it from different directions. So if you look at it from above, you see that purple square. That's what that L bracket looks from that direction. So you would be able to draw it from that direction. You would be able to draw it from other directions so that you had exact measurements of height, width, and depth. And that was how you would make a three-dimensional part. You would use parallel projection. You would use these sorts of views to be able to communicate to someone else who had to actually machine out the part exactly how it could be done. Now, maybe you could machine out the part yourself. That's fine. But if you wanted other people to be able to reproduce it, this was what was necessary. Effectively, drafting was used as a way of getting communication done, where you didn't have to worry about language. I could tell you, I need an L bracket. And you might say, what is an L bracket? Well, I need a piece of metal that is bent in the middle that can attach two different surfaces together if I put some screws through it. And that doesn't necessarily make sense either. That could be any number of things. But if you say this way, I need a piece of metal that is bent at 90 degrees, that is exactly this thick at any given point, that is exactly this tall, this deep, this wide. Suddenly you can say all of that with a picture. And as has been said, a picture says 1,000 words. This is what they're talking about. The amount of detail that you could get, the exact placement of holes. It was exactly what was necessary if you wanted to be able to replicate exactly the same part in different machine shops where no one could actually talk to one another immediately. Because it might be that everyone just had a copy of the plans and they had to work from there. Now we can fix all that. If you have a problem, we can FaceTime. We can have a Zoom meeting, and I can go into detail. I can show you a physical part, and then it could be reproduced. But this is still really basic and powerful technology. And there are different ways. For example, at this given moment in 2021, you can go to tinkercad.com. And I'm going to drop that link right here. tinkercad.com. And you can, for the cheap price of nothing, start to bring three-dimensional shapes onto a grid, connect them to one another, use them as a way to cut holes in other shapes, group them together, and build a part just like this. You can set the scale. It's going to be exactly 14 millimeters long. And then you can email that exact part to someone else anywhere in the world. You can share a link so that someone else can collaborate, make a copy of the part, change bits and pieces of it, make their own version of it, ship it back to you. Again, this is technology that anyone can access if they've got the internet. And this is technology that anyone can learn because they've got tutorials right on the site. They've got the information waiting for you. And with that, the 3D file that you save is something that can be 3D printed pretty much anywhere on the planet. There is incredible power in that. Your idea now can go from scribbles on a piece of paper to a 3D design in 30 minutes, to an actual physical part being printed out somewhere in the world in a matter of hours. It used to be, as we said, that it took 10, 20 years just to get the word out about, oh, I've discovered this amazing scientific thing. And then even longer to get something like the computer adopted. This is part of what I'm talking about. So anytime there's something you want to learn about, dig in and start learning, because there are free resources, pretty much without fail, on any subject you could want to learn about. And as soon as you start learning about it, you're going to start talking about it. You're going to tell friends. You're going to be able to find people online who have the same interests. You should be able to dig into the subject matter and really verify, see if it makes sense. Double check it. Find experts around the world and get involved if it's something that you want to make change with. So, this is what we've been discussing. Information as a resource. Around you, There may be loads of specific resources, parts, professionals, people around you who have experience. Absolutely rely on them. Absolutely learn from them, and absolutely understand how accessible they are and what they are. But more, you can reach out anywhere on the planet. If you can find an article about something, there will be a person's name attached to it. And if that person is still alive, the odds are that they're on Twitter, Facebook, LinkedIn, they're on social media platforms, and you would be able to send them a message. Talk to the institutions that they work with. Talk to the people who they have worked with. Talk to them directly. Maybe even ask them, if they're a scientist, for a copy of their paper on a subject. Because there are a lot of different journals that keep access to scientific papers, but they charge you to access them. And if you were to just write a quick couple of sentences to just about any scientist on the planet, they're happy to send you a copy of that research for nothing. It's just nice to get the information out there. That's the point of science, is to make those discoveries and make those discoveries available. This is something I want you to remember as well. The more something is open source, the more that information as a resource has value. So you have instantaneous global reach. You have real-time collaboration. You can start conversations right now. And ideally you check time zones. It's easy enough to do. Make sure that the person, isn't getting, a call in the middle of the night or something. But send an email, reach out on social media, and use Google Translate. Use online resources. There are people online as well who are willing to do translation, especially if it's to help a good cause. So reach out to who you need to and start to access the resources that you might need. For example, for your Create Your Own Sustainability project. Now, additionally, I mentioned some technologies. I mentioned 3D design. I mentioned 3D printing. But there are other technologies as well. Now, XR, VR, and AR all have very specific meanings. You're talking about mixed reality technology, virtual reality technology, and augmented reality technology. And I want to go over those really quickly, just so that you understand them, because it's very important to get these terms with the way technology is moving. If you have completely computer-generated designs, then they are closest to virtual reality. That's something that is completely artificial. For example, the part that you could design on Tinkercad is technically in the realm of virtual reality. If you were to go around a map or look around a room that had been completely digitally created, then that's virtual reality. If, however, you have video, for example, of a room, an actual room that you're in, then you could put digital components into that room. That would be augmented reality, where you're adding something digital, you're augmenting to an actual view of things. So if you're playing with Snapchat and you have a filter that, gives you the dog ears and a tongue, great. That's already AR. That's augmented reality you're playing with. Pokemon Go was an excellent example of augmented reality, where you could actually throw a ball and catch a completely imaginary, fictional, digital monster that happens to be sitting on your breakfast table. XR is mixed reality, where you're starting to use components of both. For example, you've got a virtual door that has been built into an actual room. When you look at it through the camera, you can move into a VR space. These are things that are still being played with, technologies that are still growing. 3D printing is as well. What you can see here are large 3D printed preforms that are being made, printed by this large gantry device in the background photo. Those are being made out of concrete. So this device has a tube that is pumping concrete and then layering it down in a pattern. And that's all 3D printing is. You take a device that will make a pattern that stands out very slightly from the surface. There's a little bit of height. That's one layer. And then it will go and trace over the same pattern or a different pattern on top of that first one. A little higher, 2 layers now. And then it'll do it again, 3 layers, again, 4 layers, again, until you have a 3-dimensional shape. It might be the same thing, just raising straight up like a column, like you can see here. Or it might be a more interesting shape. That's the effective power of 3D printing, is that you can do very complex shapes, and you don't have to worry about trimming material away, which was the classic means. Now, because of all of these technologies, we are in the middle of a huge economic shift that is going from the old ideas of how you would industrialize an area. Back then, it would be, oh, well, you know, we're going from farming to an industrial setup, so everybody's got to go to the big city where the factory exists, and everybody's got to get a job at the factory, and everybody's got to, you know, work extremely hard making one little part. Now we're at a point where once the design is made, once someone can create the concept, once someone can do 3D drafting, when they can do computer-aided design or CAD work, like Tinkercad, then their idea can go to any production facility on the face of the planet instantly and can be produced there, closer to home. If you've got the right devices in your community, they could be produced right there in the community. And suddenly, everything changes. It means that we're going back to an economic environment where you don't have to live in a big city. You can work remotely as long as your work is good and professional. There are options. It means also that there is a greater degree of automation because you don't necessarily need to be creating everything by hand. It can be done mechanically, but those artistic skills, the ability to make something by hand is still valuable because you can take a 3D scan of a sculpture and then place it online where people can access it, download it, make a copy of it, and tip the artist, or even sell the digital design online. Those are possibilities as well. But the automation allows anyone to be able to then make it. So you've created the original, and you can then share it with the world. It also allows for something else that's new, something called generative design. And this is something interesting. I'd like you to think about it. What does generative design mean? Now we're going to talk about it. These two parts, mechanically, are the same. You've got places for screws. You've got places for different components to attach. If you look at the strength that it takes to break these parts from different directions, they have the same strength. In fact, the one on the right might be designed to be even stronger than the one on the left, even though it uses less material. Now, the design on the right, that design that has more holes in it, that design was made by a computer. You took the original design and you highlighted some parts that need to be there. I need to be able to put a screw here at the top. I need to be able to put something through here at the bottom, and these points have to be exactly this way. They have to be this far apart, using that same kind of drafting knowledge. That part was made, and then the computer was told how the part is going to be stressed, how different mechanical forces will work on the part. And the computer was told that the part needs to be able to withstand exactly this much force. And then the computer said, oh, well, okay. And it thought about it. and it removed a bunch of components and pieces and said, well, this is the best way to make it if you want to use less material, but have it be just as strong mechanically as you need it to be. That's generative design. And this is something that is allowing computers, artificial intelligence, as it develops, to work with us and will allow us to continue creating and continue to make new and interesting changes to our world. It's important technology to know about. Generative design. Now, finally, I'd like to talk about resource sharing, because as much as we can now have instant access to information, more and more throughout the world, there is a concept of sharing different tools, sharing different materials, sharing different ideas, sharing different stuff, so that you don't have to go out and buy absolutely everything, because it makes no sense for everyone in the world to own a power drill. The average power drill, this is a device that you can use as a screwdriver or a drill. Maybe it plugs into the wall, maybe it uses a battery pack, that's fine. How much use do you think that they get on average, the average power drill? During its lifetime, how much use does it get? You would be absolutely shocked, because the average drill gets used far less than a day. So there are all these people buying them all around the world, and they just sit in a closet. Maybe never get used. For every hard worker who is out there building houses and constantly working with their power drill, that means there are enough people who buy it and never use it, that the average can be down that low. I believe the average is actually something like 17 minutes of actual use, which is just ridiculous. So, because of this, there are a lot of libraries that have been taking on the idea of having tools that you can just check out for free. You get enough of them as donations at the library. You've got someone hired who can refurbish, fix them up, and then if somebody needs a power drill for a weekend, great. They just, drop by, pick it up. Maybe they book it online from their cell phone. Great. Then they can pick it up and take all of the parts they need for the work that they're doing on their home that weekend, for the thing that they're designing. They can even talk to people there about what they're making and how they're making it. It's an opportunity for all of us to start sharing those resources. There are community gardens that have the same idea. You have a space that's shared by everyone and maintained to a degree by everyone. But anyone in the community can come through and pick fruit and vegetables to eat. Anyone can use a plot of that land to grow fruit and vegetables for their families. And it's something that makes the entire community stronger. There are places called maker spaces and fabrication labs. And these places welcome anyone to come in and kick around ideas and use the technology that they have there to make things. And we're talking about 3D printers. We're talking about laser cutters. We're talking about CNC mills and lathes. We're talking about technology that would be too expensive to own yourself, generally speaking, but that is now available to communities. And this is growing more and more worldwide. If it's not where you are yet, it will be soon. And anything that we can do to encourage it is valuable, because it will let all of us start innovating, especially this current generation of students. There are even places that will do bike sharing in a lot of major cities. You are at the city center, and maybe for the same amount or as part of your bus ticket, you can just borrow a bike, go where you need to, and then lock up the bike at the new location. And that's it. It's done. You got to use the bike without having to own the bike. It's a beautiful idea, and as much as possible, I want you guys to play with the concept. How can you simplify and share the resources that you've got so that the community benefits and so that everyone can do a little bit better? More and more, this is what's happening, and you will see as the years go on, more and more of this happening, barring unforeseeable difficulties. But I want you guys to be considering actively this global shift that has taken place, how you can be locally isolated, but globally connected. That is something very different. Now we've got the idea that we can be more than just isolated, for example, with the pandemic or in our local communities, but that we can be locally centered in the way we think. Globally connected, looking at problems that affect everyone. Because as we said in session 2, the Earth is a sealed biosphere. We do get a little bit of material coming in and some energy coming out, but effectively everything that's here is what we have to work with. So we have to work together. Any problem that any one of us is having is a problem that all of us have. So being able to communicate, spread the word, and find solutions that work for everyone is absolutely essential. And again, what I want you to be doing with those create your own sustainability projects. So think global, local, and immediate. You've got the possibility for multi-location prototyping. If you have an idea, you can get that idea out there to labs all over the planet at once, and they can all start making that prototype and iterating, ideating on it, which means making new versions, making updates, sharing different skill sets and perspectives, and they can send those back to you, and you can all be working on them together, looking at your best practices, comparing designs, and absolutely minimizing logistical costs. You don't have to send it all to one factory that will then get it shipped worldwide. You cut out all of those extra logistical costs, and people who don't even have a 3D printer can still be looking at the design, and they can still be saying, it might be better if this screw was located, half a centimeter higher. I mean, that would work, right? And then everyone can weigh in. Everyone can think about it. Everyone can see if it works best. Maybe someone who does have immediate access to a 3D printer can print both. They can do stress tests on them. They can see which one is best, and they can communicate that to the group. That's part of the power that we're talking about. And those resources are local resources. Now that they are globally accessible, now that you can reach out, as long as you have access, you can make those resources local resources. So, we have one more little game to play. And this is something that I'd like you to do, again, with someone else who you've been working with in your project, maybe a friend, maybe a parent, maybe whoever. I want you to think about the 3 pieces that we've been looking at. The one-pager is what we talked about in session 1. A presentation is just what it sounds like. You're going to have some kind of illustration, some kind of way to communicate what you're talking about. Maybe it's like the presentation I've been showing you, and you've made it in something like Canva, canva.com. Again, there's going to be a link here, and that's, again, freely accessible. So you can make something just like the presentation I made that way, or any number of ways. And the pitch. Now, the pitch is just you talking. And ideally, we're keeping it at about elevator length, which means it's somewhere between 15 seconds and 2 minutes at the very most. You want to be able to communicate everything that matters in that period of time, so that if, for example, you ended up in an elevator with someone who could make those resources happen, who could help you to get through what you need to, you could communicate and convince them to help and be a part of your project. So that's what the elevator pitch is. Simple as possible to get the point across and to get them on board. I'd like you to practice presenting as a game. Each of you will come up with an idea. Each of you will make a one-pager, and you can stretch this game out a little bit so that you get the practice. That's the part that matters. You should get practice making the one-pagers. You should get practice making the presentations. And again, use these for class assignments. Anytime you're assigned by a teacher to make a presentation, make a presentation. Do everything you can to use it to convince the people who you're presenting to that what you have found is the most important information they can be listening to keep their attention, to convince them of your thesis, your idea. And when you are presenting it, pitch the presentation. Have a very clear idea of the outcome that you require. And if it's a good grade, that's fine. A good grade is a good outcome. But think about it for longer term. You want to get better at this process. So use this as a game anytime you can. Anytime you see any of these aspects, play with them. And involve friends, compete. Make it something where you're giving one another feedback and valuable advice so that you're all growing. Play around with it and enjoy the process. Now, ideally, all of you have gotten through these stages in your Create Your Own Sustainability project. And one thing that I like to be able to do if I'm working with a school directly is to set up a competition where the administration of the school, teachers, maybe the principal, maybe some local community members, can come in and be judges. And all of the participants in this competition can present their pitches. They get to maybe have a presentation up, but take approximately 2 minutes or less, that's the absolute cutoff, to get their idea across to the administration. And at the end, maybe everybody votes, maybe the administration picks the best and brightest, but ideally at the end, you have everybody agreeing to put time, energy, and resources into that sustainability project. As long as you followed the rules that I outlined, where you're doing something that benefits your community, that uses local resources, that can grow and support itself over time, and you've already gotten started with your 5 team members. That's perfect. That's the sort of project almost any adult or businessman would be able to get behind. Almost all companies have sustainability budgets now, where they're looking for projects to support. So get your idea to them. Start reaching out. And as you do this, absolutely reach out to me. Reach out to the Time Repair Corporation. We want to see what you've done. We want to hear about it. And if there are people who we've already talked to who are looking for projects, we want to be able to connect you to them so that you can pitch your idea and get it out there. If this is the sort of material that you want to start seeing in your school, then absolutely get these videos to parents, get them to teachers, get them to community leaders, because we want to be able to be involved and continue developing this open source educational kit for people all over the planet. Thank you very much once again for taking some time to be a part of Sustainable Future, our student workshop from Zero to Civilization. I hope that you've enjoyed, and I hope that you've gotten something out of this. And more important, I hope that you continue to play and build for the future, because there's nothing at all to stop you. Before you go, make sure that you like, share, and subscribe, and check us out at timerepaircorp.com. Reach out to us, reach out to teachers and parents, anybody in your community who might find value for this material, and Help us spread the word. I appreciate it, and I'll see you all next time.